Hello everyone, welcome to my first video here on GenericCodes, and I found this really interesting problem on CodeForces. It's contest GoodBye 2023, and you can see that it's quite a while back now, but this problem is actually really good for fundamental level mathematics, and I believe that everyone should solve this if you want to test your fundamentals on divisors, primes, and in general number theory concepts. And apart from this, generic codes is not just gonna be a platform where I'm going to solve a few code forces or lead code contest problems, but rather my focus is mainly on discussing more about tech in general and discussing about maths, technology. Yeah, so moving on, let's head to this problem. I'm not gonna read the problem statement here, but I'm surely going to tell you what is happening. Well, we have to actually figure out a number x given a and b within this range that you can see, and we need to figure out what x can be. And here a and b are actually the two largest divisors of number x. Forgive me, I've coughed and cold, so I might, cough. Well, apart from that, so the inputs and everything, let's just leave this window. Let's just go to the code editor. Yeah. Now, how are we actually going to think upon this problem? How are we actually going to do that? Now, we are given a and b, where we know that b is greater than a. That is for 100% sure. You can see it. And a can also be equal to 1. We need to understand these cases mainly. So, if we know that b is greater than a, we can actually derive a very naive or maybe a brute approach to this problem, which is certainly going to give us a TLE. So, yeah, I got a TLE, which I tried on this platform, but then I quickly figured out actually a very optimal solution to this problem. I'm gonna tell you in a second, but I'm gonna discuss first the brute force solution. What can you actually do? Oh, it is basic maths knowledge that if you can multiply b by b with its multiples like b times 2, b times 3, b times 4, and so on, you're going to reach a number where probably a and b can be the two largest divisors. But caution, sorry, this is the most important thing that I'm going to say. Don't try to use your own test cases. Why is that? Because it is guaranteed in the problem statement that a and b are the two largest divisors for some number x. That means a number x is going to exist, because you know what, you can actually, if you try own test cases, you might actually find a pair of a and b as 4 and 12, and if you try solving it, you're never going to find a common divisor because it doesn't exist, right? So moving on, you should stick with the test cases given here and you can figure out the solution really quick. Well, it is not much, it is just basic maths. I'm going to tell you something very interesting for our optimal approach. I'm going to show you codes for both of them, but I'm going to tell you something really important about an optimal approach. Suppose x is a number, and it can be factorized in its prime factors, and we can write it as p1 times p2 times p3 times p4. Okay, there is another variation of x, which can be something like, p1 can exist like more than one time, p2 can also exist like more than one time, and p3 and p4. Sorry. Now, if you know that a is the second largest divisor and b is the largest divisors, can you tell me how can you actually find out what b is going to be? Well, it is a basic maths. You have the number x. If you can divide it with the smallest prime factor, for this case, let's name it as case 1, and let's name it as case 2. You can write this, you can figure out this b, it's basic maths. And if we know that this is b, That means what our b is actually going to be in terms of prime numbers. Well, it is going to be p2 times p3 times p4, right? Similarly, we can find out what a is going to be. We can divide it by the second prime number, and now we're going to have p1 times p3 times p4, right? How about we take LCM of both a and b? If we take an LCM of both a and b, what we are actually going to get is we're going to multiply the highest power of every number, right? So p1 times p2 times p3 times p4. Yeah. So what is this? What is this? Can you see something here? What is this? It is x. It is x. So we can, and we actually proved that LCM of a and b in this case is going to give us x, right? Let's talk about case 2. What case 2 is going to look like? Well, to figure out what b is, we have to do we again have to do the same thing. So we divide it by p1, right? And now what b is going to look like actually in terms of primes, well, it's going to look like p1 times p2 square times p3 times p4. Okay, and what a is going to look like x divided by, tell me what a can actually be. Tell me what a can actually be. We are certain that p2 is greater than p1. So if we multiply p1 by p2, that's like very basic maths. If you multiply p1 by p2, we are going to get a large number compared to p1 times p1. So if you want the next, basically the next smallest prime number by which we have to divide x so that we can get the second largest divisor, we need to divide it by p1 square. This is the smallest value. When we do that, we are going to get p2 square times p3 times p4. Now here, if you see the LCM of a and b, we are just trying. You know what? This is not going to give us an answer. We are just trying. If we figure out LCM of a and b, what are we actually going to get? What we're going to get is p1 times p2 square, of course. This exists in the answer, p3 times p4. This does not look like what our x was, right? And this doesn't look like what our x was. We are actually going to think of another approach where we are going to use these two equations. Yeah, let's just shift these. We're going to use these, both of these. Yeah, how are we actually going to use them? Well, well, we're going to figure out what the value of p1 is going to be. If you see what p1 can be, let's do p by a. What p by a looks like, x divided by p1 divided by x divided by p1 square, that gives us p1. Well, this is p1. Now what we can actually do is, we know that p1 is b divided by a, or we can say that b is a times p1. b equals to a times p1. We know this for sure. Now if you can see, how are we actually going to get x? Now in this x, you can see we have p1 square and we have p2 square and p3 and p4. Well, sorry. Well, we know that b by a is p1. We can replace p1 by b by a in this equation. If you can replace that, what are you going to get? B is equal to x divided by p1, that is b by a. X shared by b by a, that's a by b. That's b square by a is equal to x. So we figured out x is equal to b square divided by a. And exactly this is the answer for our case 2. Now there is one very important case that is left. How are we actually going to make sure that this is an integer? Well, we don't need to make sure of it because it is an integer, because prime factor. This is a prime factor, right? This is already an integer. So we don't need to check again and again that whether this is going to be an integer or not. So now I'm going to take you to the code, exactly how it looks like. First, I'm going to show you a brute solution that I did. Well, no. This is the brute solution that I was talking about. What I'm doing is I'm doing some bunch of edge cases initially, and then as I said, we are going to multiply by 2, and then just multiply it again and again, and then this is multiplication basically, like repeated addition is multiplication. So while true, well, this is going to give us a TLE on probably on test case 2 or 3. So you can try it on your own too. We are actually going to see this solution. So as we discussed, if okay, so when this case is going to happen, and when this case is going to happen, well, we have already seen we have to actually figure out when x is going to look like this and when x is going to look like this. It is as simple as that. Now the condition there is, if p mod a is equal to 0, that means this is a certain condition, we figured it out. Then we are going to see out whatever we figured out here, that's b square by a. Or else we are going to simply return the LCM. Well, this is an inbuilt function. You can also solve it with underscore GCD, and that is in the denominator, and in the numerator you can have a times b. So you can do that too, but this is an inbuilt function in C++, so I use this, and yeah, it gives us all correct. So I hope you got what the intuition of the problem was. So thank you for watching this video. I guess check your head out for the next video. Thank you.